All right, welcome to Data Science Club number 19. We're going to talk again about sentiment analysis using Python and natural language processing. So this is an extension of the tutorial that we did last week, except this is using more complex algorithms than what we did last week. And so
last time was really basic sentiment analysis that we were doing. We were just using removing just the punctuation marks and all those things. Today we'll be going a little deeper into it. And then last time we also we were doing analysis based on a single word. This time we might be trying out a conjunction of different words. So like if to and are together, that might constitute as one word. So
yeah, so and that's a concept called Engrams, which we'll get to. Really powerful stuff, and if you're doing any kind of text analysis, this is a good primer on how to get started with that. If you look in the description for the video, there should be the link to this Medium article that has the code that we're going to follow along with. And if you haven't already done it, you can create the base Anaconda environment that we're going to be using from the first video, I think, that we posted on our channel. So you can go through that. We may have to add some stuff today. If we didn't last week, I can't remember if we did or not. I don't think we did, but I can't remember. So let's get going. We're going to, actually, I suppose we need to check before we start what libraries might be in there that we need. So it looks like we need NLTK. Did we add that last time? I can't remember.
No, we just added RE, the regular expression library.
All right. So in order to add NLTK, we're going to just do a quick Google search, conda install NLTK. All right. So that looks like that's pretty straightforward. So we're just going to copy that. And then over here, so this is a terminal on Chiha, the UAB high performance computing resource. And you can get to that if you're at UAB by going to rc.uab.edu. And so after you do that, you can open up a terminal by hitting clusters, Chiha shell access. And if you're not using Chiha, then what you can do is open up your personal installation of Anaconda and navigate the GUI there to install NLTK. If you have problems with that, let us know. So to install it here, first we have to load our environment. Let's see, how do I make it bigger? Can I make it bigger? The text on the shell window?
Try Command plus.
No, it doesn't like it. All right. Well, I'll talk out the commands in case the text doesn't end up being readable. We're gonna do module load Anaconda 3.
We might start the interactive job
first. Yeah. Start the interactive job. That's a good point. So we're on a shared supercomputer resource, so there are other people using this. So if we're on the login node, that can impact other people's work. It would be like if I remotely logged into your computer and started playing StarCraft while you're trying to do other things. It might slow stuff down. So what we're going to do is we're just going to type in, we just Googled Slurm UAB, and that'll pop up this wiki page. And then we'll come in here and we'll just copy and paste one of these. All right, so we'll request for GPUs because that's what we like to do. And let's see, we don't need 8 hours, so we will change that. Hopefully this won't be an 8-hour video.
Yeah.
All right, so we'll just change it to 30 minutes. So the job is queued. So it's a really good point that Ravi made, that this is good practice for if you're on a shared computing resource. Just always make sure you hop over to a compute node before you start doing your work. And it shouldn't take that long. Oh, wait.
Oh, there are a lot of jobs.
Oh, there we go. Submitted. All right. So now you can see up here it said login 001, and now it says C0097. So on the UAB Chiha resource, that means now we're on a compute node. So now we will reload our module Anaconda. So module Anaconda 3. And then after that, we're going to activate our environment. So source activate NBOTW, which is what we named that environment we created it earlier in the year. And now we're going to come here and we're going to copy this Anaconda command. And so what this is doing is using Conda. This is saying, okay, Anaconda program, I want you to install NLTK, and this -C says from which channel or which library it's going to install it from.
Yeah, and if you want to, if you are the ones who have written the libraries, you can create your own channels as well where you might be offering those things. So that's where it comes in. So Anaconda channel is like the basic channel for Anaconda. So like whoever doesn't want to create their own channels or do some of the additional work, then they can just add it over here. And the part where the reason why we activated this environment was so that once we ran the install command, it's going to install it over there and not going to try to install it in a default location, which most of you won't have access to.
Yeah, if you're on your own personal laptop, it doesn't matter. You should have root access to your own personal machine.
Yeah.
But the whole beauty of Anaconda is if you're on a shared environment, you can have your own personal environments that you get to play around with. And like Ravi said, suddenly we can install NLTK, where if we were trying to do that on just the base environment for the supercomputer for everyone at UAB, it would break. So we
would update this environment YAML file in our what was the Git repo where we have this notebook of the week set up.
Yeah, so we do need to update it. It's been a few sessions, so that if you're somebody that's coming to this new, you may not have to install these, but you can always check with us before, or you can go ahead and try to install it. If something's already installed, Anaconda should just either update it or say, hey, that's already installed, you don't have to do that.
Yeah.
Let's just check, see if there's any other libraries. So that's NLTK. These are functions that this person's writing.
Yeah,
scikit-learn, we have that. Some more scikit-learn. More scikit-learn. More scikit-learn. More scikit-learn. Okay, so that should be all that we need to install there. But now we need to, let's see, first we can go to our jobs and we can kill off that job since we don't need those resources anymore. Let's see, it says that it's completed, so I think it's already stopped, right? Since I left it.
So as soon as you close that tab, it didn't have any connection, so it stopped. It canceled it.
Perfect. All right, so then I'm going to come here to interactive apps and Jupyter Notebook, and we're going to go to data user WS Monroe RC-DSC. and this is a folder that we've used a few times in the past, so you should have it if you've been following along. And 2 hours should be more than plenty. All right, let's launch this. All right, and so again, this is exactly what we did on the command line in the terminal, but just in a nice visual interface. We submitted a job to the supercomputer, and then it's spinning it up and will give us back our Jupyter Notebook environment here in a minute. Might take a minute. I don't know what the load on the cluster is at the moment, but
no, it looks like a lot of people might be using it.
okay, there we go. All right, so now we're up and running, and we can click connect. Perfect. All right, let's see. So we were in sentiment. There we go. Perfect. And I think that's ACL or ACIIMDB. All right. So now what we're gonna do, let's see, is this looks like this is a continuation of what we did last time. So what we're gonna do is we're actually just going to open up the notebook from last time and add to the bottom of it. So we'll probably have to rerun some stuff. Because if you notice up here at the top, it doesn't have anything about how do you import the data. And we spent quite a bit of time last time importing the data. So let's just rerun this stuff. Okay. All right, so again, if you were here last time you saw this, this is removing all the special characters. Okay. And then this was the model that we did last time using account vectorizer to make a metric for it. I suppose that takes a minute. I don't know how much of this stuff this other code is going to depend on, so I want to run it. All right, let's run that. And then this was the model that we created. And we can see, all right. Trying to split, and yeah, okay, so the final accuracy that we got here was 88%. So the nice thing is this work we're going to do in here now is going to follow along. So we're going to make a markdown cell here just to say now on to part 2. And I'm just going to copy and paste this in here in case we need to come back to it at some point. All right, and so now we're back to code. So what we need to do now, all right, we're in our Notebook of the Week environment, which is great. So now we can copy and paste this. And hopefully all is well with the world. All right, invalid syntax. Oh, didn't copy an F. All right, so, all right, let's see what error we're getting here. Look up resource not found, stop words not found. Okay. Please use, oh, okay. So we have to go, want us to do it this way?
Yeah, we might have to run this part.
Okay, so let's insert a cell above this. Okay. Okay,
No,
perfect. Now let's run this. All right, so what just happened there is NLTK has these stop words in there, but it's, I guess, an additional package.
Yeah, it's basically like you have dictionaries. So I don't know if you guys have used some of, if you guys generally use Android. I'm not sure about how it works on iPhones and stuff. If you are using any of the ebook apps or reading apps,
Okay.
you have to download a dictionary, and this is basically going to be a dictionary of the stop words from
Okay.
what it can identify.
Yeah, that makes sense. Yeah, so this is a dictionary of stop words, and probably it's just essentially a Python list. But basically, what this gives us is words, and in here we've selected in English.
Yeah, so that tells me that there might be some stop words for other languages over here
Yeah.
too. So
Yeah, and so what a stop word is a word that when you're speaking and when you're reading, it helps smooth out the language, but in terms of content, doesn't necessarily change things a whole lot. So if we look over here, they call out if, but, we, she, he, and they are words that might help us out if we're reading this or if we're talking, but it doesn't necessarily help the computer have a better idea of what this stuff means, since these individual meanings of these individual words can change over time depending on what they're being attributed to, like with the pronouns, or in the context that's not necessarily giving us a negative or a positive feeling, because some of these are just conjunctions and things like that. So now if we look at that Snakes on a Plane review, that was 1,300 or 13,000 rather. All right, so if we look at 13,000 of no stop words, so you can see, all right, so now, like if we go up here and we read this, oh dear Lord, how on earth was any part of this film ever approved by anyone? And then now we come down here and it's a lot shorter, or oh dear Lord, earth part film ever approved anyone. And so that's not, it's hard for us as a human to read, but if we're just looking at sentiment analysis of is this positive or negative, we've removed a lot of things that just, as far as a computer is concerned, is noise.
Yeah, and I mean, it depends upon what you are trying to achieve with your model. Like sentiment analysis, yes, he or she word doesn't matter. But if you're trying to see based on the reviews, if the main character in a film was a female or a male, in that case you might not like to remove he or she word a lot. So,
and that's a really good point, and it looks like there's a note in here that the NLTK library of stop words is more inclusive than what is in what maybe you might originally consider. And so the author of this one says that he tends to find that he gets worse prediction with using that library we just used, and he creates his own list of words that don't mean anything for the computer. That's a much smaller list, and that helps out. All right, so normalization. So let's see, what are we doing with normalization?
It's basically trying to find two words that might mean the same thing and normalizing them to one.
Okay.
And the two concepts, I think stemming is basically taking the later chunk of some of the words. I did not completely get that concept. So.
Oh, okay. Basic rules to. All right. So stemming cuts the words up into smaller chunks. Oh, okay. So it looks like what it's saying is, if a word is just a longer version of the same word.
Yeah.
So if
Giving and give might be this.
Yeah,
good
giving
consider-
and give, or exact and exactly,
Yeah.
or yeah, I don't have any other good really examples off the top of my
I mean,
head.
the just ing with most of the words that makes it into present tense is something
Yeah,
that
that
they
makes
don't really
sense.
need.
And in terms of the computer, it would create a whole new word just because you added ing.
Yeah.
Whereas from a language standpoint, you're getting the same basic meaning across.
I mean, if it says it rained or it was raining, it technically just means that the rain word should be there, and that would be one
Yeah.
analysis.
I see one issue with that, so like here,
Cannot.
can would be the stem word for cannot, and that might actually change the meaning, but we'll go ahead and give it a whirl. All right. So let's run that, and then we will stemmed reviews. After that's run, we'll check our snakes on a plane reference and see.
That is our default reference now.
Yes. Even though it's an awful movie, there's something beautiful about it. Still thinking. So I mean, it makes sense that this is going through a lot of things because it's essentially going through every word in the dictionary of all of the words,
Yeah.
as well as every word of each review. So yeah, that might take a little while.
Yeah, and there are about 26,000 reviews over here. So
Just a few. All right, so we'll keep on going, and then whenever that runs, we'll come back and take a look at it. All right, so lemmatization apparently is another way of reviewing. Oh, here we go. We'll come right back to lemmatization, but all right, so this is the stemming. So this takes, if there is a smaller version of the word, it overlaps them and just takes whatever the smallest piece is that corresponds to all of the words that have that same stem. So now we look, oh dear Lord, how on earth was any part of the film ever approved by anyone? And so, yeah, so I guess cheesy, and let's see. Okay, so apparently cannot was left in there, so maybe that's part of the stemming, that it doesn't mess with that. Qualifying, qualified, I guess that makes sense. And then it looks like it also replaces the Y's with I's because that makes it easier. Like, if you have a word that ends with a Y and it's going to get longer, you're going to switch that to an I, so that makes some kind of sense. All right.
It has stemmed a lot of words.
Yeah. All right, so now let's look at lemmatization. So lemmatization works by identifying the part of speech and then applying more complex rules. Okay, so if it's a verb, noun, right, that's a part of speech. Oh, look up here. Resource WordNet not found. All right, so we've got to install WordNet. So we're going to come here, insert a cell above, okay. I'm gonna do the really dumb thing and just Google parts of speech. I know my 5-year-old is learning this, but I'm struggling here. Okay, so yeah, noun, pronoun, adjective, verb, prepositions, got it. Okay. And apparently lemmatization is a lot faster than
Yeah, I would have expected it.
The other ones.
Different.
all right, so then if we look at
Way less timing.
yeah, a lot less things. It looks like it removes the plural.
Yeah. I still see that on the first line on earth was.
Yeah, I think it
Wow.
probably just goes through and removes any S's that are at the end of any words.
Oh.
Maybe, because tasteless still has 2 S's.
Yeah, surprisingly, I don't see much.
Yeah. Alright. These are some other ones. For some reason, in their lemmatization, less had the S's removed, but then it didn't in the stemming. Did our stemming take out? What was it?
Is there a less word?
There's crapness and tasteless here. Let's see if it got removed up here. Because that would be, it's a part of speech thing where that's like an adjective or something. So you keep the S.
Yeah.
And then this other one.
It's very difficult to find one word over here.
Yeah, no, tasteless is still there. Huh.
It looks like, just from an initial reading, the stem.
The stemming was much more aggressive for this particular review.
Yeah.
All right, so now what we're going to do is we're going to do something called Engrams, and it looks like we can do this using a feature inside of the count vectorizer, which we ran last time. So we're going to copy this and paste this over. All right, so let's take a look. So we're going to import the count vectorizer, which makes our metrics that we're going to be able to train on. Logistic regression is the model that we're using. Accuracy, train test split, and that is going to help us make sure that we're training on a data set that's separate from the data set we're going to finally test on, to make sure that we're not overfitting, but we're actually getting a generalizable model. And so when you specify count vectorizer, what you can do is specify this n-gram range, and it will say use n-grams of 1, so each word by itself, and then use n-grams of 2. So this would be taking, if there are any 2 words right next to each other, because especially in English, I don't know about other languages as much, but you might put 2 words next to each other. It might mean something totally different. So wicked is bad, good is good, but if you heard somebody say that something was wicked good, it might mean that it was really good.
Yeah.
And so that's why n-grams can be important.
Yeah.
So that's what that's doing. And then let's see. So that's creating our n-grams from the reviews, and then transforming all of the reviews into our X data set. And then in this case, we have enough reviews. We have a test data set, a validation, and a training. So this is transforming our test data set, and then down here, this is doing a test train split to make sure that we have that generalizability that we're looking for. And then down here, this is trying for different parameters of the logistic regression model. We're going to run logistic regression. We're going to fit it on our training data. And then in order to see, we're running it on our validation data to see which model was the most generalizable. And then we're going to use that generalized model to test on our testing data set, which is the other half of the data set not used for training and validation. So let's give that a whirl.
Yeah, and most of it is very similar to what we had last time. So
yeah, I think this portion of the code is almost identical. It's just using the Engrams instead. And let's see, so this is using, but we're not, in this, though we're doing the Engrams, this isn't using our normalized stuff. So one thing that would be fun to play around with this would be to take in, instead of reviews test clean, take lemmatized reviews or the stemmed reviews and see if you get better prediction that way. All right, so this is looking like we're getting better results than we did last time. I mean, it was 88% with just normal stuff, so 89% isn't a world of difference, but it's nice to see any improvement for sure.
And surprisingly, we are getting, oh, this is the word counts. How much were they getting? Was it similar?
They got 89.8, which is 89.8, about what we got. All right. So certainly you can increase n, so you could do 3, but the more you do that, the more different variables and features you're adding, the more possibility there is to overfit, and the longer it's going to take to run your model. So if you're trying to make this a real-time type thing, that would certainly make your life more difficult. All right. Now we're going to talk a little bit about representations. So up till now we've been doing the count vectorizer. And so, all right, so with the count vectorizer, it looks like what it's doing is just saying, does the word appear in the review? Yes, no. In the word count version that we're about to do here, or I guess this is just another feature of this count vectorizer, we can actually have it tell us how many times a word shows up. So let's give that a whirl. And again, so you see here, well, let's add it and then we'll talk about it. All right, so we're importing the model, train test split, and then a count vectorizer, binary equals false. So if binary was true, it would just tell us, is this word in the review? Yes, no. If it's false, then it says, is this word in the review? Yes. Then add it to the number that we have in there. So if I say that this movie was awesome like 5 times in my review, then the value for awesome would be 5.
Yeah. It's basically just counting how many times you have used, rather than just counting how many good words are there. You're also counting how many times the good words are there.
Yeah. And then you notice here, we're not doing Engrams this time, but you could certainly do both things. You could do Engrams and this word count. And then again, down here, creating the model, running it on a few different parameters, validating it, and then retraining it on the whole X data set and predicting on the test data set. So it looks like we're getting worse performance than what we saw in the original count vectorized version. Or about the same. All right. TF-IDF, term frequency inverse document frequency. Okay, so let's see. TF-IDF aims to represent the number of times a given word appears in a document relative to the number of documents that the word appears in. Where words appear in many documents have a closer value to 0 and appear in less documents. Okay, so it looks like we're giving weights to words based on how frequently they're used. If I use a word like the, and it's used in every review a few times, the weight of that word is going to be 0 because it doesn't have a lot of information in it. But what this statistic is trying to achieve is to find words that aren't used super frequently and train based on those words with a higher weight, so that you get a better analysis of things based on words that have a lot more information in them. You know, like with the example earlier of if every bad review said that this movie was wicked, as in it was an evil movie, and then all of the good reviews for the same movie said that it was wicked good, then wicked has no meaning in the context of this analysis, and so it would give it less weight. Whereas if there was other more unique words, that those would have higher weight.
And this might also be able to replace the stopgap thing that we had earlier. Like most of the people use the word the everywhere. So rather than having them removed by stopgap, this one would just make it almost completely irrelevant.
Yeah, so the stop words would automatically be weighted lower using this, and so there's not as much of a reason to take them out, at least theoretically. So let's look. So scikit-learn has a TF-IDF vectorizer in there, and then we're importing logistic regression, accuracy, train test split, and then so we set up the TF-IDF vectorizer the same way we do with the count vectorizer. I bet that there's more features here that we could play around with, more parameters. There may even be Engrams in this. We'll have to dig into that later. But yeah, so we're going to transform all of the reviews using that, and then do a train test split, create logistic regression, and train it on training data, check it out on validation data, and then retrain on our whole X data set, and then get the accuracy out. So let's give that a whirl. And again, it looks like we're not really getting much different accuracy than we are with any other version of these metrics, but all right. Oh, wow, that's pretty fast though.
Yeah. And it is giving almost similar accuracy.
Yeah. All right. So, so again, any of these things can be done with any other combination of these things. So, so we could certainly use Engrams here. We might be able to use Engrams here. We could, instead of feeding it reviews trained clean, we could feed it the normalized text.
Yeah, like the standard. What was the second one? Lemmatized.
Yeah, the lemmatized. All right. So now we're going to try a different model. We've been using logistic regression up until now, but one of the beauties of using something like the scikit-learn library is switching out our model for something different is really not all that difficult. So we're going to come in here, copy this. All right, so for this, we're going to use the count vectorizer, and let's see, so from support vector machines, we're going to import the linear SVC. Let's see, so, all right, so we're creating a linear kernel. So that's what this is, linear support vector. No, kernel is spelled with a K. I don't know what the C is here. Do you know what the C is?
No, just Google it.
All right.
Linear SVC is support vector classification.
Oh, okay. There we go. All right. So yeah, so we're doing classification. So that makes sense. We're creating a linear support vector machine for classification rather than something like regression.
Yeah. Again, the classification is good or bad.
Yeah. And so then we're training our vectorizer. We're using Engrams. We're using the binary version. So this is just checking for presence of a word, not for frequency of the words. And then we're transforming our reviews based on that. Getting a train test split of our training data so we can figure out which model would be the most generalizable internal to what we're doing. And I like this kind of methodology of doing it. You have a validation data set, a training data set, and then you split up your training data set into training and validation.
Yeah.
So you can figure out what your hyperparameters are best tuned to before you train on your whole data set.
Yeah, whole test data set, yeah.
And then here is where we're creating our support vector machine model and then fitting it to our training, checking the accuracy, again for a set of different parameters, and then getting the final accuracy. So let's run that. And I don't know how long that's going to take. But what was our, so far 89% was about the best accuracy that we've had. And it looks like that was using the Engrams up here.
Yeah. Almost 89.8.
Yeah. Still thinking, okay, now it's coming through.
This one is constantly above 89.
Yeah.
At least for now.
While that's still pumping out, let's look. So the final model that's used here. Okay, so this is what he was talking about. He likes creating his own. He or she, I don't know. The author likes creating his own set of stop words to use. And all right, we'll come back to that. So, all right, yeah. So our final accuracy was 89%. That's pretty good.
Yeah. I mean, basically, so there is nothing different in the final model apart from that he is specifying his own stop words and removing them from the reviews.
Yeah.
I don't see any other difference.
Yeah. So in here we haven't removed any stop words.
Yeah.
And in here, he's just removing his particular set of stop words. So, so you could get the same effect or a similar effect by just taking one of the one of the cleaned versions of the reviews that we saw earlier and popping it in here. Except it would be that more expansive dictionary.
Yeah.
All right, so let's just read through this real quick. So count vectorizer, that's what we've been using, and then we're also going to use the support vector machine. And so yeah, so apparently the count vectorizer lets you take out the stop words in it. So that's nice. And then we're going to fit it. So this is going ahead and finishing making our vectorized version of the text, train to split, running the model on multiple different parameters, and then pulling out the best version of the model. All right, let's give that a run. And yeah, even though this is what he ended up with for this tutorial, it is really nice to see how you could take something from up at the top of the code and plug it in at the bottom and use like the lemmatized version instead of using just the original reviews each time. So that would be something to play around with on your own, is to try plugging in different versions of the normalized stuff.
I mean, one thing that people can also try out is just for the final model, try adding more of your own stop words. So he has only got 5 or 6 stop words, but you might find some stop words that you think like, oh, they can be removed and they're not going to change some meaning and they don't really add anything to the review.
Yeah, I mean, it's potential that like since these are movie reviews, it may make sense to remove the word movie because it's not actually telling us anything. Potentially. But maybe an Engram that includes movie might tell you a lot more. I don't know. Like if somebody always is saying bad movie or good movie.
And in this final model, we are using Engram, right?
Yes. So in the final model here, so we're actually using 3.
Oh, that's one more difference.
Yeah. So up until this point, we've been using 2. So you get things like good and wicked good, but here, since we're using 3, you're also going to get things like, I'm trying to think of a good good movie review, you know, any group of 3 words that are kind of right next to each other. We can look, I know that there's 3 word phrases up here, and like "Oh dear Lord" would be a 3 gram, or "How on earth" would be another 3 gram. Most tasteless cheese. Very, very bad.
That should definitely be.
And in the end, using 3 grams and removing the stop words, we're getting 90%. But it looks like the biggest jump in accuracy we saw from last week was just using Engrams.
Yeah, Engrams.
That was what I learned, is that Engrams, out of all of these things, seem to have the most power after just vectorizing your stuff. And it may be that there's other data sets where that normalization impacts it a lot more.
Yeah.
So, yeah. All right. That's all we've got for today. But thank you guys for playing along with us. And if you have any questions, come into office hours, or leave us a comment on the video or send us an email. And if you haven't already, like and subscribe. And hopefully in the next few weeks or month-ish or so, we're going to start getting an interview every now and then with somebody from the Data Science Club or the UAB Data Science community, or somebody outside the UAB community that's doing practical data science, so we can ask them questions about how these things work in the wild and what are important things to think about when you're getting started and what to do if you get stuck, which is kind of all the stuff that we talk about anyway. So it should be fun. But yeah, until next time, we'll talk to you guys later.